Hi, I'm back, and once again I'm going to talk about design, but this time I'm going to talk about user-centered design. User-centered design is the process in which um, products and things are made by keeping the user's needs and the user's abilities as top priority, giving it the highest consideration. That is the only way in which really usable and effective systems can be built. So in Donald Norman's book, in the last chapter, he outlined seven principles that designers can use to transform really difficult everyday tasks into much simpler ones. So the first of these principles is that the designer should use both knowledge in the head and knowledge available around people in the world in order to make the system comprehensible to the user. What this means is that everything that happens within the system, within the device, or whatever the product is, should make complete sense to the user, and it is the responsibility of the designer to create an accurate to create a few mental models with the help of which the user can understand, can use logic to understand whatever is happening. So the designer should outline whatever information that the designer wants to convey to the user via the system. It should be outlined in that mental model, and it should be so simple to understand, so that when the user uses it, utilizes the system, they can mm, they can conceptualize, and they can create with their own gift of reasoning. They can create an accurate concept of how the system works, and and in a way the design model and the user's model are equivalent to each other, but it is through the system image that the designer and the user actually communicate. What the system image is that the way the system works, the way it responds, and the sorts of instructions that it carries, the manuals that it comes with, all of this forms the system image, and it is through this that the user talks to the designer, or rather the designer talks to the user. So this must be kept in mind when designing for people. And the second principle is that you should simplify the structure of the task. So if a normal task can be kept the same, but the structure of it can be simplified, then the task becomes much easier. For example, imagine writing a document in Microsoft Word and compare that to writing it with a pen and paper manually. The difference is immense. In Microsoft Word, what happens is that whenever you're typing, if you make any grammatical mistakes, most of the time if you make grammatical mistakes and spelling mistakes, they'll underline it. The software underlines it and indicates to you, and within the blink of an eye you can make a correction. But when you're writing manually, you have to check all of it by yourself. You have to do a lot of proofreading, so you are saved that you are spared that additional amount of effort and time, and you can work much faster. And also on the bottom of the screen in Microsoft Word, there's the word count, so that also helps you keep track of how many words you've written. Instead of having to manually count each word, you can just look at it and you know how many words you have covered, and also the number of pages you have covered. And additionally, you can, if you want to insert tables and figures, you can do it with a click of a button. But whereas if you had done it manually, it would take some time. You need a ruler, you need pencils, erasers, and etc. So this makes your life so much easier, and allows you to do things so much faster. So this is an example of how the task is kept pretty much the same, the idea is the same, the goal that you're achieving, that you're aiming for is the same, but the way you're doing things is a little different. So the structure has been simplified and the task has become much easier. And additionally, if say for example you're working on a laptop, the graphic display can tell you that you can look at the graphic display of the battery and you can tell about power usage, whether you can keep track of how much of the battery is left. And additionally, there another argument arises that okay, this is what I just told you about Microsoft Word. You simplify the structure, but much of it was automated. So in comes the argument of automation. Some people say that automation makes you dumb. My view to that is that excessiveness in anything is bad for you. So if you excessively automate something, that's bad for you, no doubt about that. But we all need some level of automation. Say for example, cars. At first, they used to have manual gear, but eventually automatic gear was introduced. And what that did was to after automatic gear was introduced, it eliminated the need to handle the gear manually, change the gear manually. So all you had to worry about was just driving the car, and not you just the system told you to forget about the gear. We're gonna do everything for you in terms of the gear, and you just drive. So that's good automation. That's just partial automation, not complete automation. So I always support that. But then again comes the case of the self-driven cars being developed by Google. So while that is a huge technological phenomena and it should be admired by everyone, what I think is that, you know, what do these self-driven cars do? You just get inside and you probably type in the address, or I don't know exactly how it works, but you type in the address and it takes you to wherever you want to go. So you won't have to drive at all. So I don't really support that. I think it could be, this is arguable. It could be useful for some types of people, but I personally wouldn't vote for a car industry where all the cars are self-driven. That's too much automation for me, and that can actually dumb you down. Moving on to the third point is you should make things visible. I talked about this in the other lecture, is that this is especially applicable in the case of computers, that everything that happens within the computer internally should be made visible to you up to a certain level. I remember when I bought my first computer, there were so many things that I did not understand. Like for example, I would sit down and play. In the middle of playing video games, I would accidentally press 2 or 3 keys together, and the computer would make a weird screeching noise and almost giving me a heart attack. So I wouldn't know what to do, and sometimes when I entered a CD into the CD-ROM, nothing would happen. So I did not really know what to expect. So at that time, if the computer gave me some sort of warning message that okay, this and this is wrong, or tell me that if something is wrong, then I could have rested assured that okay, I know what's going on and I can take care of it, or maybe I can tell someone else to take care of it. But to keep the user in the dark like that, it can give people like me heart attacks. So it should be made exactly visible to consumers, to the user, whatever is happening, and not only in the case of computers, in case of all sorts of devices and all. And then we move on to the point where Donald Norman says that you should get the mappings right. The user should be able to map intentions with actions, and actions with outcomes of those actions accurately. They should be able to make sense of that. So they know that, okay, if I intend to do that, so what are the, if I intend to do this and this, so what are the available options to me, and if I use this option, what will happen, if I use that option, what will happen, what are the consequences, are there any advantages, are there any disadvantages. So this should all be made crystal clear to the user. Then we go to the using of constraints. The designer should make the system in such a way that sufficient amount of constraints are used, so that users are limited to a few sets of actions, and so that this can narrow them down to doing only the right thing. For example, in our university, in the computer lab, there are very few things you can do with the computer. What they do is that you would need an administrator's password to get into a few restricted areas. So they don't the university authority, the IT department, they don't want you to they don't want you messing around with that. So they directly restrict access from that. And plus there are many things you can't do. You cannot delete a system file or folder. You can't even access it, and then you are only limited to just one drive in the hard disk, and you cannot install your own software or your own games. So they applied these constraints for the best of the university and for the best of the computer, because you never know who does what. So it's always good to be on the safe side. So this is an example of where the constraints were used to narrow the user down to a limited set of actions. Moving on, we have on the next point we have is you should design for error. The designer should plan ahead. He should be able to predict what wrong actions, what undesirable actions the user might perform, and they should prepare for it. They should if there are any actions that are irreversible, then the designer should do everything in their effort to make sure that the user is fully informed about it. And in situations, in the case of errors, the designer should provide a sufficient mechanism through which these errors can be recovered, so that users are not left tearing their hair after little moments of carelessness. So and because we are humans and we always make errors, so this should always be kept in mind, and it should be made sure that if someone works for 6 hours on a document and in the end they just press one button and everything is gone, so that's a huge loss. So no one deserves to face that situation. So that's why designers should keep that in mind. And the final point is that when all 6 of these fail, then the only option you are left with is standardization. No matter how difficult it is to operate your device or your invention, if you standardize it, if you create an international standard, then everyone will have to learn it. There's no alternatives. Like, for example, take the bicycle for example. It's very difficult to learn how to ride the bicycle at first for everyone, but no one can say that, okay, this is difficult, I don't want this, I want another one, because there is no other one. Of course there are those with training wheels, but that's for kids. So if you set an international standard, then everyone will have to learn how to operate that, and you can rest assured that everyone will know how to operate it. Those who know operate it, they'll be able to operate it anywhere in the world. They'll face absolutely no problem. And it's the designer's way of saying that, okay, you don't like this, doesn't matter, everyone else in the world is using it, so you've probably just got attitude problem. And so yeah, so that's about it, about standardization. And then I'm going to conclude this video with one last topic, which is making things deliberately difficult. Sometimes it becomes necessary to design things in a difficult way. Say for example, this concept is applied most widely in in the area of game development, where you have to make games difficult in order to challenge the gamers, challenge the users, so that they feel competitive and so that they derive enjoyment from the game. So you have to make them. You have to have variable levels of difficulty. So, and with each passing stage, it has to go from the difficulty level has to go from easy to medium hard to very hard, and so on. And there is another case, another example which is present in the book, is that sometimes in schools for special children, you might have to, or not just special children, for little children, you might have to make the doors in such a way that the door handle or the door knob is at the top, so that the little kids, they cannot reach the handle, and as a result only grown-ups can reach that. So therefore, if any child even wants to get out of the door, they cannot, because it is the handle is way up there. So this is another case where you must make the design very difficult in order to protect the children. So with this, I want to conclude my video here. This is all I'm going to say about user-centered design. And thank you very much for bearing with me.